Okay, so here's another example for surface area. The first example we did was, I think, very straightforward and easy. The second example looked a little more difficult, but we turned it into polar coordinates, and it turned out to be pretty easy also. I wanted to give you something where there was a little more work involved in figuring stuff out. Okay, so here's the next question. This is problem number 4, I believe, out of the homework assignments or homework exercises. Find the surface area for the part of the surface given by 2y plus 4z minus x squared equals 5 above the triangle with the following vertices, 0, 0, 2, 0, 2, 4. So starting off, there's 2 different things we need to do. So eventually we're going to need the partial derivatives with respect to x and respect to y. And then we're also going to need to know the region that we're bounded within. So I'm going to start over here on the right-hand side with the vertices. I'm going to sketch a little region real fast to see what we're talking about. So I have here at 0, 0. I'm over here at 2, 0. Then I'm up here at 2, 4. So I'm bounded by that triangular region. That's the base that I wanted to say, okay, well, this surface, what's the surface area above that region? So looking at this, it strikes me like we should do this as a type 1 region. If I notice my x values, they're going from 0 to 2, right? And then I can talk about the y values. Well, my y values are going from 0 to the equation of this line, which is y equals 2x. So I have bounds. X is going from 0 to 2, and then y is bounded by 2x on the top and 0 on the bottom. Okay, so that's my region. That tells me how I'm going to rewrite my dA into my iterated integral. The next thing I need to do is let's move over here and talk about our relationship. To find partials, I need to write this so that it's z equals. So I'm going to manipulate. This tells me that 4z is equal to 5 plus x squared minus 2y. I'm going to divide everything by 4, so I get z is equal to 5/4 plus x squared over 4 minus y over 2. So that gives me my relationship as a function of x and y. So let's look at partial derivatives now. So the partial with respect to x is going to be, well, that's a constant that goes away. My 2 comes down, so that's a 1/2. So that's x over 2. This is just negative y over 2, so that's considered a constant, taking the derivative with respect to x. My partial with respect to y, constant, 0. X squared over 4 is a constant if I'm paying attention to y, so I'm just left with a minus 1/2. The next thing I'm going to do, so those values, when I plug them into my equation, have to be squared. So I'm going to go ahead and square them right now. So that's going to give me x squared over 4, and then that's just going to be 1/4. So that's telling me for my formula for surface area, inside the square root, I need partial x squared, and then I need partial y squared. So if I write my formula out now, over r, actually, let's just write it straight as an iterated integral. So on my integral, again, y is bounded by x, so that's going to be this inside one, my y function, or my y integral. So from 0 to 2x, and then my x values are bounded from 0 to 2. These little letters here are going to make it helpful for you to remember which ones you're doing, okay? So let's look at this. That's the square root of, I'm going to have x squared over 4 plus 1/4 plus 1 dy dx. Everyone's okay with that? Here, that is 5/4. So my common denominator is that's a 4/4. So let's write this as 5/4. And notice the first thing I'm taking the antiderivative here is with respect to y. I have no y's there. That's only a function of x. So what I can do is, well, that's just a constant. So my antiderivative is going to be that constant times 2x minus 0. Okay. So let's go ahead and write that. The next thing I want to do is, so now I just have a single integral. This feels a lot like Calc 1 now. I want to try to simplify this a little bit. If I notice both of these have a 4 in the denominator, so what I could do is, this is really going to be the square root of 1/4 times x squared plus 5. Follow? So then this becomes a 1/2 on the outside. So really, I'm going to write this as, we can still see right here, 1/2 the integral of 2x square root of x squared plus 5 dx. Look, those are going to simplify. What I'm going to do right now is go ahead, if you want to finish this section, finish this problem up. I'm going to wipe up the board and move that up to the top so we can finish. And here we are with our clean board. In my excitement writing that down here, I forgot to put the limits of integration on that last integral. The x values are going from 0 to 2. So I went ahead and added this back up here. So now this looks like a situation we found a lot of times. I'm going to have to do a u substitution. So I'm going to work through this relatively quick. You can pause anytime if you want to. I'm going to move the 1/2 to the other side because I have x dx in my problem for a substitution, right? So then I can rewrite that, move the 1/2 to the outside from x equals 0. X equals 0 to x equals 2. And then I have on the inside just the square root of u, du. So antiderivative, or I can write this as 1/2 power. Then we can use power rule. Awesome. This will become 1/2 power rule gives me 2/3 u to the 3/2 evaluated from x equals 0. X equals 2. Let's simplify this and plug my u back in. So that's x squared plus 5 evaluated from 0 to 2. So when I plug in a 2, so that's 1/3 times 2 squared plus 5. Oops, 3/2. To 3/2 minus, so I have the 1/3 on the outside, so now I'm just going to plug in 0. So 0 squared plus 5, 3/2. 4 plus 5 is 9. The square root of 9 is 3, and then 3 cubed is 27. So that gives me 27/3 minus 5. So the 3/2 is going to be 5 square root 5/3. This is just 9 minus 5 square root 5/3. There you go. If you have questions, maybe we could start using the discussion board. Okay, there's an idea. We'll just throw it out there. Send me an email if you need anything, if you have questions or concerns or anything about the course. Those are now examples for surface area. Yeah, that's it. Cool.